Welcome to our Azure Incident Retrospective. I'm David Steele.
I'm Sami Kuba. We work in the Azure Communications team.
In addition to providing a written post-incident review after major outages, we also now host these retrospective conversations.
You're about to watch a recording of a live stream where we invited impacted customers through Azure Service Health to join our panel of experts in a live Q&A.
We had a conversation about reliability as a shared responsibility. So this includes our learnings at Microsoft, as well as guidance for customers and partners to be more resilient.
We hope you enjoy the conversation that follows.
Right, on June 16th, let's have a look. Our West Europe region experienced two different networking outages. These connectivity issues on June 16th and then again on July 5th. Now, as Sami mentioned in the introduction, although these were two pretty unique incidents, they're both chapters of the same story here. So before we introduce our panelists for the live discussion, let's hear again from Dave Maltz, head of our networking team, to introduce us.
The next two incidents we'll talk about occurred in the West Europe region, one on June 16th and one on July 5th. Azure is always growing. As a result of that, we're constantly monitoring the utilization on our network to make sure that we have enough capacity on the links that physically connect our data centers together to carry all the traffic that you and your services may place on Azure. We're always, during this incident, or certainly before these incidents, we detected that the utilization on the network links in the West Europe region were going beyond the target load that we designed those links in order to carry. When this happens, as it often does, we began a process of capacity augmentation, planning to add more links into that network in that region so we could carry the traffic from your services. We use automation to manage our network, basically a data structure that describes what the network is supposed to look like, and our automated systems work to make sure that the network always looks like that desired state, that desired topology. For this reason, one step in a capacity augment is to extend that data structure, that network graph topology, to show the new links that we're planning to add into service. During this particular incident, when the expanded network topology graph was checked into our services, it showed that those new links that were going to be added were already in production, even though they hadn't been physically connected yet. We have extensive redundancy on our network, meaning there are many, many links connecting all the endpoints together. For this reason, when our network automation systems detect a combination of healthy and unhealthy links, often the correct response is actually to turn off healthy links in order to maintain balance across the links in our network. In this case, unfortunately, because so many links had been added with this in production state, even though they were not physically present, our network automation systems did what they were intended to do, which was to go through and actually begin shutting off healthy links. Now, our network automation systems have guardrails and safety checks on them, so when they detected they were taking too many links out of service, they paused themselves and alerted our engineers. Our engineers engaged, realized what was going on, and began the process of putting the healthy links back into service. They had to work carefully while doing this to ensure they didn't accidentally put back into service links that had been correctly removed from service because they were sick or otherwise unhealthy. Putting those links back into service could have had a negative impact and actually made the situation worse. The time at which this incident occurred was in the early morning of the West Europe hour. As the day went on and West Europe woke up and began its business day, traffic on our network began to increase as it does every day. This resulted in a race, essentially, with traffic levels increasing and our engineers working to put links back into service to prevent impact. During this period of time, there were definitely periods where utilization on the links exceeded what our network capacity could handle, and packets were dropped as a result. That's why you and services running on top of our network would have seen periods of loss, interspersed with periods of time when the services worked well. As a result of this incident, we paused the capacity augmentation work. Now, we knew that we were at risk of another congestion incident like that first one if anything happened to the links inside the West Europe region. For that reason, we prepared a special playbook for what would be due if we lost some links in the network, and we trained our incident managers on that playbook so they could respond quickly if another issue occurred. On July 5th, we had to put that playbook into action as a large summer storm hit the city of Amsterdam in the Netherlands, which is where our West Europe data centers are located. As a result of that storm, many trees were knocked down, their roots tearing out our fiber from the ground as they fell over. That caused the loss of about 25% of the fiber links that connect our data centers together in the West Europe region. While part of our team worked with on-site crews in order to restore fiber, we knew that it was going to be a long time to restore the physical links due to the many trees that were downed and blocking roads and unsafe working conditions around the fiber break. For that reason, we also had engineers working to turn off all the discretionary traffic in the West Europe region that we could, and to work to maintain as much balance between the links that remained in the West Europe so we could handle as much traffic as we possibly could. The situation was restored and the impact mitigated as we were managing to balance the traffic on the remaining links and working to add on links using whatever capacity we had available. People now will tell you more details of what happened, how we responded, and again, the repair items we're taking to keep this from happening again. Thank you.
Big thank you to Dave Maltz again. And with that, I would love to introduce our two panelists who are going to join us for the discussion now. Our first one is Jitu Pade, our Partner Software Engineering Manager. And joining us remotely is Frank Ray, our Partner Technical Program Manager. Both of these folks are from the Azure networking team. Thank you very much for joining us.
Thank you.
Cool. Great to have you here, Jitu. Good to see you online. I can see Frank over here. So before we get into more detail on the incidents that Dave described, Jitu, could you help us to understand the network architecture here? Kind of what are the different bits and pieces? What are the characters involved? And then we'll delve into some more detail.
Okay. So for the incident that happened in West Europe on June 16th, the key piece of technology that we need to understand is something called a LAG. It's a link aggregation group. It's also known as port channel. So it is a bundle of links, Ethernet links or fiber optic links that act together as a group or as a concert. Okay, and we use this structure to make sure that it is easy to add or remove capacity in a region that's as needed. So what happened in this particular incident is that we had a bundle of links that were set up between two routers. And two sets of routers. There were about 512 of these. And each of these lags initially had only one link. And we wanted to add capacity to it. Right? And as we wanted to add capacity to it, the plan was to add a second link to each of these lags. The operation was supposed to be completely transparent to our customers. That's the reason these lags or these link aggregation groups are set up. Okay? As Frank will explain later on, this is something exactly the step at which we went wrong. So the key piece of technology that we need to understand why this incident happened is link aggregation groups, lags. They're also called port channels.
Got it. Great. Now that we understand what a lag is, I'm interested because I wanted to know kind of where we had. No, I don't need it. That's a perfect answer. Thank you very much.
Super. Thank you very much. So if we go, Frank, can you tell us that it's great to understand kind of the theory and some of the actors in this piece. But if we forward to the day, we're adding capacity. We're about to kind of add some new topology in. What actually happened?
Yeah, so normally when we go and make topology changes to the network, we have a new network topology description, which gets added into our automation systems. So this is in the form of metadata, which gets added, or in Microsoft speak, gets checked in to our systems to tell our systems what the network will be looking like. This usually happens after we've set up the links so the systems know where the cables are connected to what ports, what the lags look like, et cetera, and then the metadata gets checked in. In this instance, unfortunately, a step in the process happened out of sequence, and the metadata was checked in prior to all the connectivity and configuration work being completed. This caused our automation systems to look at the network and see the network in an outage state because the capacity that was told to be in place was not there, and the systems began to mitigate as they're designed.
Super. Thank you very much. There was one piece when I was reading the PIR, Jitu, I'll speak to you about it. It was interesting to hear because our network, as Dave has mentioned, as you mentioned, as Frank has mentioned, it's largely automated.
Yes.
And so when something hiccups, hiccups happen all the time. Automation kicks in and everything kind of works smoothly. Where this one happened, it was interesting. The way that I interpreted it was during the incident, there were humans kind of fighting against the automation, but I wasn't too sure if I've understood it correctly. Could you help characterize it for me?
So it is true, as Frank explained, that it is automation that kicked in. So as I explained the concept of lags before, And when we added these links, these were added in an incorrect state. So our automation detected that these lags were imbalanced in some sense. And when the lag is imbalanced, the standard thing is to take the lags out, which is what essentially the operation that triggered and started taking these lags out, even though the second link was not in production. So now, when this happened, the automation killed those links very quickly. Everything that you saw was the aftermath. The automation was, it's not like the humans were fighting the automation. It was not like we were putting the links back in service and the automation was taking them out. There was nothing of that sort what that was going on. We were able to determine very quickly that the automation was at fault. Automation was red buttoned, if you will. It was not going on. And then the rest of the process was in terms of link recovery.
Got it. That's great to focus on the recovery once we understood that. So a question for you, Frank, then. You explained kind of what went wrong initially. So could we now flip that around? What would you say that we learned, right? What are our kind of process changes or repair items that we're putting in place, I guess generally so that future capacity augmentation is done more seamlessly?
Yeah, so we absolutely understand the impact that an incident like this has on our customers, their services, and their business, especially in a region the size of West Europe. And we've had a lot of learnings from this incident, and we're applying them towards the repairs. For example, we've already made changes to this specific augment process to ensure that steps cannot happen out of sequence and that metadata check-ins do not have an impact on the production network. We've also made enhancements to our alerting for packet loss detection to improve our time to detect. Additionally, we're working on enhancing our rollback capabilities for on-call engineers so that they can react more quickly to when events are happening. Additionally, we're making enhancements to our safety gate mechanisms for our auto mitigate systems with respect to network utilization and capacity headroom so that our systems can act more adeptly. And lastly, we're also working on an auto declare feature for regional incidents so that we can provide updates to our customers more quickly and more transparently as far as what's happening in the network.
Super. Thank you very much, Frank. So with all that in mind, that was the first part. And then we had a second incident in West Europe, which was somewhat related, chapter 2 of the story. And in chapter 2, if we fast forward to, I think it was called Storm Polly, it was hitting the Netherlands. And there was a fiber cut. Now, it's interesting, were there one fiber cuts? Were there many fiber cuts? Could you help characterize the storm for us? Because surely fiber cuts are commonplace. I'm just interested to know about this one in particular.
Yeah, well, this was certainly one of the worst storms in Dutch history, right? And the conditions were really bad. So in the Netherlands, there are 2 geographic areas where the clusters of our data centers are located. And between these 2 areas, we have multiple fiber paths. It was one of these fiber paths that was impacted by the storm. A tree was uprooted and pulled the fiber path completely out of the ground. I believe we also have some pictures so people can see what things look like on the ground there. And as far as the duration of the event, the conditions, as you can see, were quite bad. So not only around the area of the fiber cut, not only were there downed trees, but there were also downed power lines. So you couple this together with the high water levels that were present in the area, and this created a life and safety risk for our network service provider. They had to wait for the conditions to improve to ensure that there was no risk to their crews. At that point, they dispatched their teams and worked quickly to try to fix the fiber cut with the inline splice that you see here today.
That's great to understand, and cool that we had the photos up there as well. So question for you, Jitu. It sounds like, based on what Frank was saying, we knew that the repair might take some time, right, to get people into the area, to do it safely. So how did we respond as far as temporary mitigations to try to reduce utilization, right? How do we alleviate congestion if it's going to be time before the fiber is fixed?
That's right. So as Frank explained, not all fiber paths were cut because of the storm. There are multiple fiber paths between the 2 regions that we have here and between the 2 islands that we have here. And since only one of the fiber paths was cut, there was a little bit of imbalance. So the very first thing that our engineers did was to shift as much traffic as we could so that the imbalance was kind of naturally taken care of. And that reduced some of the impact. The second thing we did is that we worked with our internal properties, SharePoint, some of these storage jobs that are required to keep our storage balanced across multiple clusters. All of these jobs were discretionary or whatever, were either turned off or they were migrated out of that region. Okay, that reduced the amount of bandwidth that we were consuming on those paths further. So between those two actions, we're able to mitigate the impact somewhat. On the other hand, as we discussed in the context of the earlier incident, the region was already running hot. So despite all our best efforts in terms of immediate mitigation, the ultimate mitigation was always the bringing the capacity back and adding it back. So
it's interesting, and I think, Frank, I'm going to turn to you. We spoke about the region running hot at the moment. One of the questions we're getting a lot from customers is, are we sufficient? Do we have enough capacity now in the region? Are we another fiber cut away, another storm away, another poly V2 away from this kind of impact in West Europe? How is West Europe doing now?
Yeah, so prior to the event on the 16th, our goal was to go in and double the overall regional capacity to ensure that we brought the region back within our design targets and de-risk the situation. I'm pleased to announce today that we've completed 95% of those augments, with the remaining 5% scheduled to be completed within this month. This has allowed us to bring network utilization back down within our design targets and de-risk the situation in West Europe. Furthermore, we actually used the updated process that I spoke about earlier to perform the augment, and those happened as planned and as designed, and everything was invisible to our customers. So we feel much more confident today with the state of the region for our customers.
That's great to understand for West Europe. I know a lot of our customers and partners run services in multiple regions here. So I guess if we can kind of zoom out a little bit, Frank, are there other regions that are similarly at risk, that are kind of, one potential fiber cut away from being overutilized? Or was West Europe really kind of uniquely hot in that regard?
So I would say that fortunately and unfortunately, West Europe was a very unique situation in that we were running hot. This is not a situation that we see across our fleet. I will state that across our entire global infrastructure, we see over 40 fiber cuts per day, both in our regional networks as well as across our wide area network. As a matter of fact, we're having an incident in our UK South region today. We have seen utilization increase, but the network is designing as performed, and this is being invisible to our customers with no impact. Once this is repaired, we will see utilization go back down, and this will all happen invisibly to our customers. So we feel that West Europe was a unique situation, but we've done enough capacity augments to de-risk the situation today.
Great, that breathing room was already part of the plan. Good.
Super. Great to hear about the UK as well. Jitu, in our PIRs, when we speak to customers, we always say, hey, when there's an outage like this, here's something that you can do. And these are some things that customers can do to add extra resiliency. If customers had implemented some retry logic, some exponential backoff logic, would that have helped them in this situation when it comes to packet loss?
Yeah. So retry logic, and especially exponential backoff and retries, are always good things. You always want to implement those, but they typically help if the congestion is transient. Lack of the capacity is transient meaning lasting maybe for a few milliseconds, which can happen due to temporary imbalances or whatever. But in this particular case, there was a long time outage, and so retries or exponential backoff or standard application level techniques like that would not have helped so much. What would have helped is if the customers, like our properties, first-party properties, were able to fall back from one region to another. There are other regions, Europe North, for example, that we have in Europe that were not heavily overloaded, which is why our internal properties were able to fall back there. If customers implement the same architecture, essentially providing a regional level redundancy and resiliency, that's the way to go, is what I would suggest.
Got it. So that's a great, not to put all your eggs in one basket. That multi-region recommendation is something that we include in a lot of our post-incident reviews that only impacted one region here specifically. Great. So Sammy, I'll turn my attention to you here. Again, since you run the comms team, the way that Jitu and Frank have been describing it, when there's congestion, there is some packet loss. How does the comms team approach that? Do we know whose packets were lost and who we can kind of send updates to? How did we do in this incident?
There's a few things to cover here in comms. The first very kind of tactical thing is that, once again, we went to our public status page quite early, which was a good thing because the impact was broad and we didn't fully understand what was going on. We sent out portal communications triggering those Azure Service Health alerts, but they came in late. Now, for the chapter 1, the early one that happened when we were adding capacity, our brain, which is our automated system, which communicates to impacted customers only, that was firing rather quickly because there was some VM connectivity loss and there was some control plane failures. So if customers were trying to create or delete something, all of that was firing. And so customers were getting a lot of communications there. When we, on chapter 1, when we were communicating in the beginning, we took a different way of communicating than chapter 2. And what I mean is when we have issues like a WAN outage or like an AAD outage or an Entra outage, where it's very broad and multiple services are impacted, it's tricky to communicate. And on one of the chapters, we communicated each individual service because customers have given us feedback to say, hey, I can't access my VM and I can see a big green check mark next to my VM. And it's tricky because for some customers, their VMs are working, it's rendering a movie like it's supposed to do. And for other customers who have an application where they're processing like orders from a customer on a website, they're saying, hey, I'm down. And so it's always been very tricky. So in one of the situations, we checked every individual service and we said, hey, these services could be impacted because of the WAN outage. We discovered some tooling issues and we discovered some kind of issues where a lot of customers would have received a huge amount of communications from us because of the number of combinations of virtual machines in West Europe and storage in West Europe. We didn't aggregate that very well. And so it was very noisy. The second chapter that we had for the part 2 of the outage, when we had the fiber cut, those scenarios hadn't fully onboarded to Brain yet. And so customers wouldn't receive those automated communications. And again, we went to our status page first, and then later on, we went to our kind of targeted comms. We need to figure out the right way to communicate impacted services. And I think one of the things that we're going through now is to figure out, hey, do we light up all the services or do we keep it broad? And I think one of the things that I ask our customers to do is please give us feedback. We design these systems so that they're useful for customers so that customers can make business decisions. And I think whatever we decide is going to be imperfect. But at least I'd like customers to kind of give us input so we can create a system, we can document it so customers can know what to expect. So that's something that's a work in progress. The other noteworthy thing that we try to do is as our Brain system, our automated comm system, it's still growing. And I think for the most parts, over 70% of our outages are communicated automatically within 15 minutes via Brain, which is wonderful. But at times it cannot correlate or aggregate very well. So we'll have storage communicating for Brain and VMs communicating for Brain, and it doesn't know it's part of the same incident yet. When during the outage, the first one, we tried to close the gap and tell customers, hey, we tried to correlate and point to one tracking ID and say, this is the tracking ID. And we also tried to tell customers after the fact, hey, we saw that you weren't impacted. You might have a resource in West Europe, but you weren't actually impacted by this. And so we wanted to send out communications to say, while you received communications during the incident, after the fact, we've determined that you weren't impacted and so on, just to give that closure. And I think it's a process that we're new at. We're trying to build that muscle, and it's imperfect. We've got a lot of work to do there, but this is the direction that we're heading in, where we can tell customers, hey, you could be impacted, and then after the fact, giving customers the right closure to say, we over-communicated in the interest of speed and making sure everyone is notified. We've conducted an investigation to say it's safe to say you're not impacted. But those things are a work in progress, but that's the direction that we're heading.
Thank you for watching this Azure Incident Retrospective.
At the scale of which our cloud operates at, incidents are inevitable.
Just as Microsoft is always learning and improving, we hope our customers and partners can learn from these too and provide a lot of reliability guidance through the Azure well-architected framework.
To ensure that you get posted incident reviews after an outage and invites to join these live stream Q&A sessions, please ensure that you have Azure Service Health Alerts set up.
We really focused on being as transparent as possible and showing up and being accountable after these major incidents.
Whether it's an outage, a security, or a privacy event, Microsoft is investing heavily in these events to ensure that we earn, maintain, and at times rebuild your trust. Thanks for joining us.
Thanks.